Last time we saw the TensorFlow Quantum is to generate quantum ML models. ML machine learning, quantum machine learning models. What is a quantum machine learning model? Let's learn together. I'm your Sue and this is Hello AI. A quantum model has the ability to represent and generalize data with a quantum mechanical origin. To understand quantum models, two concepts must be introduced: quantum data and hybrid quantum classical models. What we are going to see today is just quantum data. Let's try to understand that first. Quantum data exhibits superposition and entanglement, leading to joint probability distributions that could require an exponential amount of classical computational resources to represent or store. Wow, I did not understand anything. Let's see in detail. What is a superposition first? I said quantum data exhibits superposition and entanglement. Superposition states that any two or more quantum states can be added to form a new state. For example, light is a wave as well as a particle, so it is a wave particle. You can separate that one. And similar is the entanglement. What is an entanglement? It is when a pair or group of particles is generated or interacted or shared in a spatial proximity. That is distance. Spatial proximity is distance like close distance or long distance. You cannot independently take them into account. That is, you cannot describe each particle or a pair or a group independently, even if you take them to a very large distance. Again, you can keep the light as example. You cannot say light as a wave, you cannot say light as a particle, and you cannot separate it. And light is always going to be a wave particle. Who knows, in future it can be another particle too. So light is still a mystery, and light is a very good example of superposition and entanglement. I mentioned previously in quantum data, what is this exponential amount of classical computational resources to represent or store? Oh my god, it's quite a very huge word. So let's simplify that. Exponential amount is a very rapid increase. So let's say you can put e to the power of 10. It's a huge number, of course. How it increases? It increased like 10 times more, and you don't know how much e increases. So a quantum data is a data which contains very huge data that can rise exponentially. So that's why we are having a joint distribution here. Of course, joint distribution, because what is a joint distribution? Joint distribution is a probability distribution which can take two probabilities together from a random axis. So you can take this into account as joint distribution only because you are taking superposition into account. There is going to be two or more quantum states added together in a TensorFlow quantum computing. So we should always use joint probability distribution in here. It's quite complicated in here right now, but in few days of explanation we are going to be very clear about what is this joint probability distribution and what is an exponential increase, etc. So that's all for today. I hope you got a very little out of this, and in further days we are going to be more clear. So that's all for today. We are taking quantum models slow and steady. Good night, America, and see you tomorrow. Bye bye.